Hello friends, in this video we are going to talk about the geometric series. Okay, before we know what's the geometric series, we have to know about the geometric sequence. Likewise, we saw in the previous one for arithmetic sequence. So that arithmetic sequence have same different, but here the geometric sequence is a sequence with a how can we say, like constant. Okay, the constant ratio between between two consecutive or two succession terms. So that is called a geometric sequence. Okay, how can we write this? As like the first term is a, so the next term is ar, and the other one is ar squared. It will goes up like that. If you see the ratio between the first two are r and the next two are also r. If you have the same ratio, yes, it is the geometric sequence. Okay, so next we get into the geometric series. We know what is the connection between sequence and series. So we know if we add those sequence, it will give the series. So see, if we want to get the nth term, it will becomes like ar to the power n minus 1. Okay, so next we have to know about the sum of a geometric series. So if we write Sn, so we can write as a plus ar plus ar squared plus it will goes up to ar n minus 1 power of. Okay, so that will be our first equation. So we have to multiply that by r. So if we multiply, you can see r into Sn, that is equal to ar plus ar squared plus ar to the power 3. It will goes up to ar to the power n. Okay, it will be our second equation. So if we subtract first equation from the second equation, see there's a the second term of the first equation and the first term of the second equation can be deducted. So if we write Rsn is equal to there will be, if everything will be deducted, there will be a r to the power n minus a will be ended here. So sorry, I forgot to put the r minus 1, is it? Okay, so if we do the arrangements, it will comes as, if we take a as common, r to the power n minus 1 over r minus 1 will be there. So we can rearrange the equation like, if r is greater than 1, we can write Sn is equal to a into r to the power n minus 1 over r minus 1. Okay, if r is less than 1, we can write that Sn is equal to a into r to the power 1 minus r to the power n over 1 minus r. So if you don't consider that thing also, you will get the same answer. So here we are going to see an application of a geometric series, which is the calculation of acquired amount. Okay, so to that we will get a formula. So if we see our principal amount we will take as P. Okay, there will be capital P. Okay, so we will take about annual interest. Okay, we annual interest as I should be in ratio. Okay, 400, no, in a ratio, not in a percentage. We cannot put. Okay, so and the next one is at the end of first year, what will be our interest? Yes, it will be our it will be P into I, because we know that I is in ratio, so we can straightly apply that. Okay, so at the end of first year, what will we get as a acquired amount? Okay, that will be P into PI, no? So P plus PI. So we can, if we take as acquired amount as A, so A will be equal to P into 1 plus I. Okay, so if we calculate the acquired amount for the second year, okay, at the end of second year, okay, you will see. So at the beginning of the second year, what will be our principal? Yes, this A will be our principal amount. So we have to find the interest for A. So principal amount will be P into 1 plus I. Okay, so we know how to calculate the interest. So if we calculate the annual interest amount will be P into 1 plus I into I, because the annual interest won't change yearly. So our acquired amount at the end of second year will be this P into 1 plus I plus PI into 1 plus I. So if we rearrange them, we can get P into 1 plus I as a common thing. So there will be 1 plus I will come again. So we can write this as P into 1 plus I, all things squared. So you see, if we take this 1 plus I as R, we can write them like P into R to the power 2. Okay, so if you see the end of n years, if we end of 2 years, you will set PR squared. So at the end of n years, you will get PRN. Okay, so we can write them as A is equal to P into Rn, R to the power n. So it will be right A into P into 1 plus I to the power n. Don't forget that I should be in ratio. Okay, so we will see a question for a simple example question. So if our principal amount is rupees 1000 and our annual interest is 10%, and we have to find out for the 5 years. So if we take the annual interest, it will be 0.1. So the accurate amount at the end of 5 years will be 1000 into 1 plus 0.1 to the power of 5. Okay, so if you calculate this, it will be 1.1 to the power of 5. So there will be 1000 rupees, 1610 rupees and 51 cents nearly. Okay.